I'm gonna go through the first two levels of how you of hijacking or demonstrating this vulnerability. You don't actually exploit this vulnerability until much later on in this lab sequence. But the very first, and the reason why I really like the way PortSwigger does this thing, it's really scaffolded nicely. The very first level is to trick a victim into a GPost request. And so the idea is that you're smuggling an orange fragment that is basically a single character, G, and then the victim is coming in along with a post. And then because you have attached a capital G as your fragment, this will result in an error from the victim as the victim is going and hitting your thing. And so the idea is that the attacker will first prime the connection between the front end and the back end. And it's going to prime it using this. So again, post request. It's got both a content length of 6 and a transfer encoding of chunked. And the content length of 6 is actually going to get you to beyond this G. So there's a bunch of carriage returns here because all of this is part of the content length. And so the 6 specifies this as all being the payload, and that gets you to this G. And when the attacker does this, then when the victim comes along with a post, you'll see that the post will directly follow the attacker's payload. Okay, so when you send this set of data through the front end, and the front end is doing CL, then what you get is two separate posts. You get the initial post, which is here in green. Whoops. Oh, I don't have this animated well. So the initial post, which is in this blue, and sorry, I tried to use the color coding that PortSwigger was using on their site, but I can, this is really hard to discern the shades of green and blue. But you can see the first post ends at this G, and then the second post is the green. So that is the front end CL interpretation of what's going on. But then in a transfer encoding approach, what you get is you get a single post here, which is in blue. And then the second part of this is the orange, which is the dangling G. So this is what the backend sees. The backend sees upon the first payload, the shorter post, and then it starts this second payload with a capital G. And then when you get the post from the front end, this post is then attached to the original G, and then you get this G post as part of the next payload. And this is going to trigger the level solve, because then you see that the victim has been tricked into a G post. Okay, so let's go and show this in action. So this is the payload. I have a post, this site. So once I fill in the site, actually, let me start this up while I explain it so we're not waiting. Okay, so then this is going to be done over SSL because, so one of the things is I am actually speaking raw HTTP. I cannot use Python requests to do that. I actually have to use the low-level Berkeley sockets abstraction. I have to do the speaking of HTTP over a socket, the raw bytes. And so this is something that we showed really early on, the raw, no, actually, I didn't show this early on, but this is what I'm doing. I'm actually speaking native HTTP over a socket, and I have to set up the SSL over the socket. So that's basically what's happening here. I set up an SSL context that I'm going to use as part of this socket connection first. And then this is the post data that the adversary is going to send. So that's that priming the connection with this post. And you can see that it's got the pattern that I mentioned before. It's got the content length and the transfer encoding both in there. And then I'm going to create, using the socket package, I'm going to create the socket and use the connect method of the socket. I'm going to connect up to the HTTPS port of that site. And then I'm going to get this SSL context and I'm going to wrap the socket with it. So this allows me to send regular plain text through the context, and the context is going to do the encryption for me and then actually send it down the wire. So that's what it's doing here. And then I'm just going to say, you know what? I am going to encode this GPost data using HTML encoding. And then I'm just going to get the response. And then I'm going to just print the response as that I get back. And then I'm going to do this is I need to trigger a GPost. And so what I'll do is I'll just use a regular client, and this will be the victim coming in and then hitting the main page. And so I'll use Python requests to do this, to actually get the connection and then finish the level. So let me do that. This is my site. And then, so that's my program. And if I run this thing, you see unrecognized method gpost, because that was the victim request, and it got this error message back. This is the response I got from the initial thing that primed the connection. And then you can see that that actually solves the level. Okay. Questions about that? Because I do have 5 minutes. I'm going to do the next level then because I have time. Here's the next level, and let me start this thing up. I want to start this up on this site so I don't have to wait for it to launch when I get to that point. All right. So this vulnerability reverses the two. So this assumes that the transfer encoding is done on the front end, and then the back end is doing a content length encoding. And so when you have this configuration, the vulnerability is a little bit different. And this is the sort of the exploit that you send instead. So in this case, the attacker is priming the connection with an entire bogus post that's this gpost thing. And so the first thing is that in a transfer encoding world, this is a single post. Because if you look at this, there's this transfer encoding chunked. So if you ignore content length, and this is what the front end is going to do, transfer encoding chunked, the first chunk has length 5C. And this is actually going to get you all the way to the x is equal to 1. And then the next chunk is a null chunk. And so this is actually a single request to the TE front end, followed by a victim request. So then when the victim comes along with a get slash, you will see that this is basically the next, this is two separate requests. So in a content length world, so let's do this exact same sequence on the backend content length server. The content length version of this has a content length of 4. And so what this does is it just gets you beyond the 5C. And that is followed. So this is in a content length backend. The backend says this is your post. And then this is your orange fragment. This gpost is the rest of this, because this content length has got 99. And then what it's going, so this is the fragment that's on the back end. And then when the victim comes along with another get, that victim is going to attach this payload to the rest of this content length. And then you'll get this invalid gpost on the back end. And that's how you would solve this particular level. So let me do that. So I brought up this site. Let me copy it so I can just solve this immediately from the other page. And this is the program. Let me walk through the program at first. Let me first fill in the site. Okay, so as before, I create a context. One of the things I want to do is programmatically identify the content length and the length of the smuggled chunk and all of these things to make sure the chunk lines up. And so I have a null chunk defined as being that 0. And then I also have the smuggled chunk defined. And the smuggled chunk, I could actually programmatically set this to be the length of the victim. I don't actually know the length of the victim request that follows me. So just as long as I put this up as to something fairly large to capture the victim request, I'm fine. So I put it at 99. But I do have to specify this smuggled chunk because I actually need the length of that chunk in order to do the chunked payload properly. And so I need the length of that chunk, and I need it in hexadecimal. And so that's what this is doing. I'm getting the hexadecimal version of the length of this chunk. So this is a string, and this is basically a string in bytes. And then I'm getting the length of it in decimal. I am returning the hexadecimal version of this, but then the hexadecimal version of it has a 0x in front of it. And it turns out the transfer encoding length doesn't like the 0x in front of it, so it just strips it out. And that's what the lstrip does. And that's my smuggled chunk length. And then what I'm going to do is I'm going to create this bogus, this is the entire request. I'm going to create that post. I'm going to specify the content length of 4. And then I'm going to use this transfer encoding chunked. And so the content length of 4 assumes that this is going to be this is going to be 2 characters actually. Because then I'm going to just include the smuggled chunk length directly that I calculated here. And then I'm going to include the smuggled chunk and then the null chunk. And that's my attack payload. And then what I'll do is I'll deliver that payload as before. And that's what this thing does. And then subsequently, I'll make that request. And then that request will get the G post. OK, so let me run this thing. And so that primes the payload. And then when I hit return, you'll see that the G post is returned off of this. And you can see that this programmatically sets it to 5C so that this null chunk ends up being parsed subsequently. So then the chunked encoding works because I've specified these lengths appropriately. And then if you go back, you see that the lab has been solved. Okay, that's all I have. That's the end of the course. I hope you found it useful. I'm looking forward to your final projects. Definitely fill out the course evaluations if you haven't. Fill out the attendance. And if you're around in the fall, I hope to see you in person eventually. If not, if you're graduating, I hope you have an awesome graduation and have a good summer. All right, catch everyone later. And I'll hang around here if you have any questions.